So we're going to talk about a little bit of a deep dive of Chef and AWS and some usage patterns that we see on AWS to make you more successful with AWS's services. So the agenda for today is we'll do a quick introduction. We'll do a quick recap of some of the paradigms in Chef. So when I'm using nomenclature, you guys remember what that means. We'll do a quick introduction of ourselves. And then we're going to talk about user management with Chef, managing versions not only in Chef, but also versions of applications as well. We're going to talk about something really awesome called test-driven infrastructure with Chef. And then give you a sampling of some AWS cookbooks that'll help you use AWS resources inside of your Chef recipes or cookbooks. And then lastly, we're going to talk about something called Chef provisioning and how you can provision machines, load balancers, and other components of AWS directly inside of recipes. So a quick introduction of who we are. John will introduce himself here in a minute when we go into the demo portion. But I'm Michael Ducey. I'm a partner evangelist for Chef. There are my pertinent details. If you want to, tweet, love this session or session was horrible, feel free to tag me on that. And then John Kaiser as well, who is our chief mad scientist. So let's talk about the building blocks of the components of Chef. So at the very base level in Chef, we have something that's called resources. And resources are just objects that we want to manipulate. The object can be local on the operating system that you're running on, or it could be something that you've abstracted away, like something that you're going to manipulate via an API call, like we'll show when we talk about the machine resource that we'll talk about later. Those get collected into what's called recipes, and then recipes are essentially the collections of resources that you run to make something happen on your machine, right? So you want to have Apache installed, so you would have resources to start the service, to install the package, and to change your httpd.conf file. Those recipes then get collected in what's called cookbooks, and cookbooks are essentially the packaged component, the recipe, and all the other supporting files that you need to install a particular application. And then you can collect cookbooks and also something else called attributes and what's called roles. And basically you can say this machine is a web server, and you can apply the role to it. And you can say, I want the recipe Apache. I also want recipe users. I want recipe like sudo as well to set up all the other base components. So every time that you need a web server, you just apply the role web server instead of having to worry about all the little individual components. And then all the machines or nodes we call, inside of Chef, we call machines that we're managing, so the instances that we're managing, nodes. And those nodes belong to an environment. So environments allow you to kind of abstract out usage patterns, so dev, test, production, and kind of all your standard typical environments that you see. And there's something really cool in environments where you can lock environments to particular versions of cookbooks, which we'll show here in a second. And then lastly, data bags. So data bags are somewhat of an abstract thing to explain, but when you understand what they do, they're really, really powerful. It's essentially just a JSON object store or a data store. So you can put arbitrary JSON formatted data in there, and you can retrieve it and use it. And I'll show you an example of how you can actually use those, actually 2 examples. So the other important thing when you talk about Chef is that it is infrastructure as code. So what does this mean? So it's the ability to programmatically define your infrastructure configurations where you are using versioning, focusing on code reuse as well, so creating libraries, and then also source control management, right? So it's beginning to abstract our infrastructure inside of a code base, and then we treat it like a code base. And the nice thing is that when we do that, we should be able to recreate our infrastructure from 3 things: a code repository, which is all your cookbooks and recipes and so forth, a data backup, which AWS has many ways to help you take data backups and things like that, and then compute resources. And AWS has a lot of compute resources as well. So if for some reason something happened to your environment, like somebody decided to delete everything, and this is a true story, I've heard this story multiple times, where somebody goes into AWS and they delete the production environment. And they're like, whoops, and terminate all the production instances. And within an hour, they're back up and running because they had a data backup, and they had all of the cookbooks and everything that they needed in the code repository to recreate their environment from code. So this is an important concept to keep in mind as we talk about how you work with Chef. So let's talk about our first topic, so user management. So managing access to instances can be rather problematic. When we talk to AWS solutions architects, this is kind of the #1 use case that they want to try and help their customers solve. So how do you grant access, SSH access, manage people's keys on machine, and so forth? And especially not just, you just don't run in one region or availability zone, you have to do this globally now as well, right? So the challenge is we want to try and provide user authentication and management that's going to be resilient to failures as well. So if your LDAP server goes down, you still want to be able to log into the machines. So by default, Chef has some nice resources that allow you to manage users and groups, right? So there is a user resource. I can create Han. I'm going to put him in the group Rebels, and his home is Carbonite. And he's a hipster, so he uses Z Shell. And then we have the group Rebels, and we're going to put Han, Luke, and Leia in there, right? So we can manage these, and this is cool. This works fairly well. It doesn't give me any ability to manage SSH keys. Also, if I have to delete Han because Han, decided to get angry with Leia and, fly off from Hoth, and then he changed his mind and he comes back, right? But if we have to delete him, it's problematic because I don't have that state of whether if Han should be created or deleted, and this kind of becomes untenable. So what we have is we have a cookbook, right? So it's a community-created cookbook. Fletcher Nichols in our community is the one who actually created it. And it allows you to store the user data in a data bag. And this is one of the awesome things about data bags, is now I can store this kind of arbitrary data that I need to configure my system inside of Chef, and then I can query it and use it inside of Chef as well. So the user cookbooks allows me to create, update, and delete users and the user's SSH keys. So all I need to do is describe Han inside of a data bag. So you can see all of the same fields that I was describing over on that other screen are here as well. And any other arbitrary data that I wanted to put in here about Han as well, like maybe his password to get into the Millennium Falcon computer system, right? And if it was a password, the awesome thing is that you could actually encrypt this inside of Chef as well, in what we call an encrypted data bag. So when we take when we use the user's cookbook, it actually gets a lot more simpler, because now all I have to do is that I would just want to say that I want to manage the group Rebels, and I'm going to remove and create. So inside of here, I could specify if I wanted to remove Han, and if I say that I want to remove Han, when this actually reads this data, it'll go through and remove Han for me, right? So all I have to do is mark this person as deleted in my data bag, and then he or she will be deleted off of all of my machines in my fleet. And then now the nice thing, it'll go through and create all of my Rebels as well, very easily. So it queries the data bag. It says, show me all of where all give me the users where their group is Rebels, and I'm going to create or remove them. So that's user management. Let's talk about versioning with Chef. So if you have any questions, feel free to grab us afterwards or come by our booth, and we can talk more about some of these things that I'm talking about here, because we're kind of glancing over some of this stuff, so we can have a bigger conversation later. So problem with versioning with Chef. So different instances often need different versions and applications of applications and cookbooks. And the reason is because I might be testing my cookbook, and I don't want it to leak into my production environment and break my production environment, right? So I want to be able to control, as I'm making changes and testing changes to my infrastructure inside of Chef, I want to control when I push that into the production environment. So versioning with Chef, so cookbooks are versioned, right? Everyone hopefully knows this. It leverages what we call semantic versioning, and if you want to learn about semantic versioning, there is a URL there that is completely washed out. So it's semver.org. So if you just search for semantic versioning on your preferred search engine, then it'll allow you to find this very easily. But versioning allows environments and also machines to run different versions of cookbooks based upon what they need to do and what their role is in the environment. And it's commonly, as I said, used to test cookbooks in lower environments before I actually push them into a production environment. So what I can do inside of Chef is I can describe what we call environments. So you can lock an environment to a particular version of a cookbook. So I could say here that because I'm in dev, I'm going to say my app is 1.1, and in prod, it's going to still be at 1, right? So I'm going to test these changes in my lower environment and then push them up. There's also tooling. There's a tool that we ship called Burkshelf that helps you manage dependencies as well, and also locking environments to versions, so preventing people from uploading new versions of cookbooks and changing an environment. So you can freeze an environment to make sure that it's always stuck at that and you can't squash that accidentally. So this is a very simple way of how you just use versioning in cookbooks. Now, you can also specify inside of roles and other places to say use a particular version of a cookbook as well if you don't want to do it on this global level. But that's just my cookbook. So how do we want to version application data, right? So I have a particular WAR. It's on a remote resource somewhere, so it's on an artifact server, maybe it's on S3, and I want to download this WAR, and I want to put it into my Tomcat home, right? Wherever my WAR home is set for. So I've got my URL, and I've also got the current version here as well. So in Chef, we have something called attributes, and attributes are pretty powerful. It allows you to basically write how you want something done, and then the data of what actually gets done is stored inside of an attribute. So I can just bump this version, and I'll get the next version of my WAR, right? The problem is if I store this data inside of my cookbook, I actually have to release my cookbook, right? And basically do a release of my cookbook, bump my cookbook version. And if I'm producing this WAR a lot, then I'm going to be updating my cookbooks a lot. So we don't want to necessarily store that data in the cookbook. The other problem is that when we're using a cookbook attribute, we can't link together other applications. So who has an application where it's just one application, right? Very few of you, I think, right? You have systems of machines that work together that all run a different application that creates a service, right? And so you want to be able to abstract the idea of the service and the versions of the different services that you might have running in your environment. So data bags are another solution to allow you to kind of collect all of this information about a particular environment and also the application. So I can actually take dev and prod, and I can say my app, the WAR itself is going to be 1.1 in dev and 1.0.9. I don't know why I pick numbers that are so hard to say. Don't roll off the tongue very well. So I can choose different versions, and then inside of my data bag, or inside of my recipe now, I can actually consume this. So based upon the environment that I'm running in, it will get back the appropriate data bag. So that's what's happening here is essentially we're querying, we're trying to find the item, my app, inside of my data bag, and this will actually pull that back. And then basically the version will get pushed in. I saw something that wasn't syntactically correct, so it threw me off there for a second. But this is a good idea of how you would do it. The Chef people in the room will realize what's wrong. So let's talk about test-driven infrastructure with Chef. So test-driven infrastructure is something that is getting extremely popular, and it's gotten extremely popular in the last year. If you haven't checked it out, I really encourage you to kind of take this talk and use the links at the end and learn more about what we're doing in that space, because it's really, really cool. So really what test-driven infrastructure is about is bringing the best practices of test-driven development to the infrastructure and operations world, right? So now that I'm doing infrastructure as code, and I'm treating my infrastructure configurations as a code base, I can then begin to use the other paradigms of software engineering to make my development of this infrastructure code better, and that's what we're doing here with test-driven infrastructure. It also helps me provide a workflow of best practices so that as I'm sharing content with other people, I'm doing things that are nice to them, right? And trying to be a good developer with the other people that I'm working with. So if you don't know what test-driven development is this mantra of red, green, refactor, right? So the first thing I do is I write a test, and that test will fail because I don't have any code to actually run that test against, right? So you write the test of the state of the way you want things to be when the code is actually written. And then then you actually go make the test green by writing the code that makes the test pass, right? So we're writing our tests first. And then we go and we refactor and we, because premature optimization is the root of all evil, so we don't want to prematurely optimize. We go back and we optimize later, right? And then we just continue this kind of cycle every time that we need to add a feature or a change. So this is bringing this into the infrastructure world. So the old workflow for developing chef cookbooks was we'd write some cookbook code. We maybe do a vagrant up, right? Vagrant provision if I have the machine already working. I verify that it works. Maybe it breaks. I go to pre-production. I do some more ad hoc verification. I go to production and then broken production, right? The new workflow, which is like a cake filled with M&Ms, yeah, that's M&Ms. That's how good it is. So we write some cookbook code. We run some tooling to test for cookbook correctness. And we can write and run some unit tests as well to make sure that when I'm configuring my system, it's actually behaving the way that I think, right? We go into pre-production. We can run these integration tests. We can run the same unit tests and the code correctness in an automated system like Travis or Jenkins or something like that to actually verify and also take in changes from other people as well, because we're not developing cookbooks in isolation. We're developing cookbooks as a team. And then we can actually verify that things are going to work correctly when we bring in the set. And then when we brought in the set, we can then go to production, right? And our chances of success are higher. They're not 100%, but they're better, right? And there's some tools of the trade that you should look at if you're interested in test-driven infrastructure. So two of them, Food Critic and RubuCop, they're basically sanity checking to make sure that you're using kind of community best practices, not only in the Chef community, but also in the Ruby community as well. There are unit tests. So Chef Spec basically is a version of RSpec that we've extended RSpec to actually make sure that your Ruby inside of, or your resources inside of Chef are actually behaving correctly. And then we have some integration test tooling as well. So one of the tools of the trade is Test Kitchen. Test Kitchen allows you to basically run the other integration tests like ServerSpec and BATS. And ServerSpec is a really cool tool where it'll actually go to your machine and actually verify that this port is actually listening the way you expect it to, or this package actually got installed, or this service is actually running as well. ServerSpec is a cool one to look at because also people use it sometimes in a monitoring environment as well to actually verify that things are behaving the way you expect them to. So let's show a quick example of how you can extend this. So this is an example that I think is actually really cool. So I want to check to make sure that I'm doing some sort of compliance check. So I wrote compliance rule number 1. And what I'm going to do here is, of course, the boxes didn't line up in the final cut. So I'm going to find all of the resources that are type mount, or I'm going to find where I'm actually calling an execute block, and my command is mount. So I want to check to make sure to see if people are putting things in a recipe that I don't want them to do, and one of the things I don't want them to do is mount things they're not supposed to, right? Because they mount up a volume or a USB key or something and copy all my data off. Of course, we don't have USB keys in AWS, right? So we want to check to make sure this doesn't happen, right? And so we're doing these mounts, and what's cool is that when I'm running my integration tests and all my testing, so an automated environment can actually pick my cookbooks up, run this test, and the people who have control of this isn't the same person who's writing this, right? And then I can actually verify if we're violating policies, right? So maybe you could extend this to say, I don't want certain ports opened up, or I don't want people to do certain things inside of their recipes to basically break compliance and break our security because we have the standard way of doing things and the standard way that we want to work. Make sense? All right, so let's talk about AWS cookbooks. There's actually a lot of cookbooks out there inside of what we call Supermarket. So Chef has a community site. It's called Supermarket, of course, because we're chefs. And it contains a lot of community cookbooks. Some of these are maintained by us, Chef, and some of them are contributed by the community. So the first one is the AWS cookbook, and I'll give you examples of each one of these. I'll also give you links to each one of these as well. So the AWS cookbook allows you to manage load balancers, so register machines on a load balancer. You can also manipulate elastic IPs and register a machine against elastic IPs, create EBS volumes, do EBS RAID, change resource tagging, and so forth. The security cookbook allows you to manipulate security groups and rules. The RDS cookbook obviously allows you to manage RDS and create new RDS services. And then lastly, the Route 53 cookbook. So let's look at examples of each one of these. So we can pull down our data bag item to get our keys. This is optional. Ideally, you want to be using IAM roles. And if the machine is part of that IAM role, then you just need to have the role allow them to register themselves to the load balancer. And then we actually perform the register. So basically, all I need to do inside of my recipe on the instance is say the name of the load balancer and that I want to register against that load balancer. So every time a machine comes up, it can discover its load balancer. You could actually have this as part of a search. So you could search and get the load balancer name that you know, and then register against that load balancer. For security, for manipulating security groups, it gives you the resource security group rule. And you can just write out the rule as you see here. Also, to note, you can also use IAM roles as well, so you don't have to put your keys directly inside of the recipes, which isn't really a good practice. And then same thing with RDS. So you should always run your RDS instances on a T1 micro. And basically, you just specify this information. The other thing is, so the DB info, then the name, you could store all of this information in a data bag or another attribute that then you can then search on and pull out. Since this is a database password, you should probably store it in an encrypted data bag, right? So using kind of the queries that I showed earlier where you're getting the data bag item out. So here we have creating a Route 53 record. So very self-explanatory. The nice thing is that if the record already exists and you're just needing to update it, you can actually override it, which will just update the record as it exists. And then lastly, all of these have URLs down at the bottom. And then also at the end, I'll give you a URL for each one of these cookbooks as well. So let's get back in the presentation. There we go. So let's talk about provisioning in AWS. So launching new instances in AWS, you can go to the console. There's EC2 tools. There's lots of different ways that you can launch instances inside of AWS. When you want to launch more than one instance, and maybe you want to launch a collection of instances that perform some sort of a task, that can kind of be a little bit more problematic. So with Chef, the common way to launch instances is just to say knife EC2 server create, pass in the AMI, the instance type, and the other data that you need, and it'll go out and it'll provision a machine. Wrap this in a for loop, and you're provisioning machines all day, right? So pretty easy and pretty simple. It's great for one-off server creation. It's also great for tools that may not have direct integration into EC2. So you can use this, and you can, it's a command line that you run, right? And as I say, it's more like infrastructure as command line, not infrastructure as code. And that's kind of problematic. What if I want many instances, or what if I want tiers of instances that are performing a task and providing a service? Then that doesn't work too well. And this is where Chef provisioning comes in. So Chef provisioning allows you to create instances inside of Chef recipes, and not only instances, but load balancers as well. And you can also manipulate machine images as well. So it allows for more programmatic creation, and then you can also create multiple tiers. So because Chef execute things in order, you can create the database server, and then you can, once that's done, then you can, and only once that's done and successful, then you can go and create the web servers that might be talking to that database server. So it allows you to kind of also sequence creation of machines now as well. And it's moving us more towards real infrastructure as code. So when the term infrastructure as code was coined, everyone's like, yeah, but it only kind of manipulates my operating system. It doesn't actually manipulate all of my infrastructure, right? So this allows us to move more towards infrastructure as code. And the other thing that I think is really interesting about Chef provisioning is that it allows you to consume resources in a manner that best fits people's workflow. And for most people, a lot of people now, their workflow is becoming code, right? So I don't need a command line. I don't need to learn how to do API calls or anything like that. I can just write code that I'm used to, and I'm already writing recipes. Why do I need to go learn and write something else, right? So the way it looks, and we're going to do a demo of it here in just a second, but essentially all you need to do is specify a machine, the name of the machine, what recipes you want, and it'll go out to AWS or other places and create the machines for you. And with that, I'd like to call John up to the stage. And John's going to give you a quick demo of it. You're doing good on time.
Okay. All right. Thanks, Michael. Sorry for killing your keynote. Yeah, so I'm John Kaiser. I'm chief mad scientist at Chef. And about a year ago, we started a journey to create Chef provisioning because, well, we build distributed applications at Chef, just like the rest of you. And I was in the middle of building one and noticed that I wasn't testing it very much. And I wasn't testing it because the method for bringing up new machines was mysterious to me. And I didn't trust the place where we actually recorded how to do that, which was in a playbook. There was a wiki page that we had where we would put those nice EC2 commands, and they would have, first of all, 50,000 parameters on the command line, most of which I didn't understand. I knew how to write my application, but I didn't know how to provision it yet. And so the whole thing was scary to me, so I would test it on my local machine instead of actually bringing it up the way I should have. Honestly, it made it so that the process towards the end was, it was a worse experience, because once it was done, I still had to write the recipes. I still had to get them up there. If I'd been doing it from the beginning, it would have been better. And the fact that we needed a playbook was weird. Like, if only we had a tool where we could write down what our infrastructure looks like in code. And it turns out we do. So what we decided to do was build resources to build the things we wanted, which were machines. And that's where Chef provisioning was born. You can see in this sample recipe that I've got here, we're going to build 2 web server machines with a simple web server on them, and then we're going to attach them to a load balancer. Many of you were here a little early, and you saw a bunch of little green text flowing down the screen, and that was actually me preparing the machines in the demo, because it takes 3 or 4 minutes to create a machine. You also saw me doing it multiple times, because the first time I put too much on the machines, and I wanted to have them half provisioned for you so I could show you more. Provisioning your demo 10 minutes before the speech, that's trust in your product. So the things the primary concepts in Chef Metal are the machine resource, obviously, that gives you a machine, puts recipes on it. But it has to work in conjunction with somewhere, right? You've got to be able to get it up on AWS somehow, or get your Docker containers up somehow. And you have to say what they're going to look like. So that's where the Chef drivers come in. And that's what this first thing is. This says with driver AWS. And what that's going to do is going to pull the AWS credentials out of my configuration so that I don't specify them in the recipe. And then all the resources, whenever I make a machine or whenever I make a load balancer, and you'll see it's commented out, and we'll uncomment it in a second. It's going to use all those credentials, so you don't have to put them in the recipe. You can also point this at Docker, and you can also point this at different regions. So that's where you can see with data center. You can use Chef provisioning to provision machines in different data centers. This is designed both to be a mixed mode, so you can put things in different places, that are all part of your same app. Like maybe you put a monitoring server in one region and a lot of your resources in another, or you gedistribute your web servers. It's also meant to be repeatable. So if you switch out that with driver, then you can, or switch out that with data center, you can point this recipe at one region and then build the exact same cluster in another. That's why this is just Chef. It's repeatable. So you can see here that I'm creating those two machines in a loop. I made my machine names. This is Chef. It's code. And the code here, I said I want to make 2 web machines. You can imagine lots of ways I can do this. I can dynamically create the names and dynamically scale the number of web servers I have. And then we do a loop to create the machines. We put in a machine batch, which parallelizes the creation because it kind of sucks to create 100 machines in serial. 3 minutes each is not bad, but 3 minutes times 100 sucks. Without further ado, I'm going to run the recipe, which is what you guys wanted in the first place. What I have right now, and let me switch out to show you that, is an expired session. That's fun. Just 1 second. Sorry about that. In fact, while I'm doing that, I'm going to you know what? I'm not going to show the things in AWS, and we're going to move on. I disabled LastPass so that you wouldn't have a bunch of stuff in the way. And so what I'm going to do here is bring this up with the new load balancer and with the simple server recipe on each of these machines. So I already have the 2 instances on AWS. I do not have the load balancer yet. And so I'm going to run the Chef client on that same recipe. What I did was I just uncommented out the simple server recipe. So now what Chef is going to do is going to notice that the 2 machines exist already. This is idempotent. And that they don't have that recipe on it yet. So they're going to add that recipe to the run list and reconverge the machines. And what that's going to do is put the simple server and Python and a bunch of other fun things onto the machine. You can see here it's starting the Chef client on the second web machine. And it's going to do this in parallel, so you'll see in a second the Web 1, some text from Web 1 going on at the same time. So this is the basics of it. You can run this multiple times to scale as well. While we're waiting for this thing to go, I want to show you what that trick looks like. If I want to scale, because of the idempotence of Chef recipes, and what that means is that when you run a resource a second time, if there are no changes, it will do nothing. If the thing that you want to exist, the machine that you want to exist, already exists, then we sure better not make another one. If it doesn't exist, then we create it. If it exists and it's not exactly the way you want it, if it's not running all the recipes that you want, then we will update it. And that's what idempotence is all about. So you can see there we ran the Chef client on all of these machines. And so we're going to save this sucker, get that third guy in there since we got a little time, and then I'll bring Michael back up here while it's running in the background. But I want you to see the actual third machine being created while we're looking at it here. Well, that's what happened. I didn't save the recipe last time. Cool. There's Web 3, and we're reprovisioning Web 2 and stuff. And by the end of this demo, you get to see the load balancer up there.
Thanks, John. So this is really awesome. And as I said earlier, it allows you to really kind of treat your infrastructure really as code. So now I have repeatability in creating things in AWS, right? As John said, I can take this exact same recipe and I can now move it and point it at a different region. And I could maybe even point it at something that's internal if I needed to use something internally as well, or locally on my local machine as well, and create the exact same cluster that I might be creating somewhere else. So in conclusion, just to kind of wrap up, so the one main thing is that Chef is a journey. So the user paradigm, I showed that to some people that have been using Chef for a while, and they're like, I don't understand why that's a problem anymore. But as you get started, you tackle these kind of smaller pieces, and then you move up the chain to more complicated pieces, right? So usually start with the easier paradigms that are easier to solve, and work your way up to the bigger paradigms, such as application management or creation of instances inside of recipes. And the other thing is you need all of these links that you can't see. So we'll leave this up if you want to come up and get the links. We'll also post the slides. So look for them on Twitter. I'll use the hashtag #reinvent, and then also use our name as well. You can find me pretty easily. And I'll post the links for you guys and gals so you can use them. So thank you very much, and thank you to John as well.